Ever wondered how AI tackles a 100-page research paper or a novel without losing its place? It's not magic, it's math. Today, we're diving into a breakthrough that's rewriting how neural networks process long, complex texts. Imagine teaching a robot to read a book without it getting distracted by the wallpaper. Let's unpack the science behind this transformation. Here's the challenge. Traditional AI models, like those powering chatbots and translation tools, rely on softmax for attention. Think of softmax as a floodlight, spreading focus evenly across every word. But here's the problem. As sequences grow longer, this approach collapses. It's like trying to read a book in a room with 100 flickering lights. The more words there are, the harder it is to spot the critical details. This creates three major issues. 1. Representational collapse, where all tokens blur into indistinct noise. 2. Oversquashing, a memory bottleneck where distant context gets lost. 3. Attention dispersion, spreading focus so thin it's like listening to a symphony with headphones on. But what if AI could shine a laser instead of a floodlight? That's where Alpha-Entmax comes in. This method isn't just a tweak, it's a fundamental shift. Unlike softmax, which forces all attention weights to sum to 1, Alpha-Entmax allows many weights to stay 0. This creates sparse attention, where the model zeroes in on the most relevant words while ignoring the rest. Think of it as tuning out background noise to hear the key conversation. Here's the twist. Alpha-Entmax isn't a one-size-fits-all solution. That's where ASEntmax steps in. Imagine an adaptive spotlight that adjusts its sharpness based on the task. For short text, it's a tight beam. For long ones, it broadens just enough to keep track. Pair this with NAPE, a positional encoding that blends where and what clues, and you've got a system that's both flexible and precise. The results? Mind-blowing. In tests, models using ASEntmax achieved 76.7% accuracy on a 65,000 token task after training on just 64 tokens, a 1,000x extrapolation leap. This isn't just better performance, it's a paradigm shift. By avoiding softmax's pitfalls, these models handle long contexts with unprecedented clarity. So what's next? Imagine AI analyzing entire legal documents, scientific papers, or even novels with the same nuance as a human. This research isn't just about faster models. It's about unlocking AI's potential to understand and interact with the world in richer, more meaningful ways. Thanks for watching. If you want to dive deeper into how these techniques work, check the description for links to the paper and code. And if you're curious about AI's next big breakthroughs, hit subscribe. Until next time, keep exploring. Ever wonder how AI models see the structure of a sentence? It's not just about words, it's about position. But here's the catch. Machines don't inherently know where each word sits in a sequence. That's where rotary position embedding, ROP, and a clever trick called Alpha-Entmax come in. Together, they're rewriting the rules of how models focus on text, creating attention windows that act like flexible spotlights. Let's break it down. Imagine a sentence as a line of words, each needing to talk to others. Traditional methods spread attention smoothly, like a dimming light. Farther words get less focus, but it's all gradual. But Alpha-Entmax, it's more like a spotlight with a sharp edge. Beyond a certain point, attention drops to 0. It's not a fade-out, it's a switch-off. This creates sharp attention windows, where the model zooms in on specific regions. Now here's the magic. ROP encodes position using rotation matrices. Think of it like a compass. Each word gets a direction, and the model calculates similarity based on those angles. But when you combine ROP with Alpha-Entmax, something cool happens. The rotation frequencies determine how wide those attention windows are. High frequencies, tight focus, like a macro lens capturing nearby details. Low frequencies, a wide-angle view, sweeping in distant context. It's like having a camera that switches between close-ups and landscapes on the fly. Why does this matter? Because real-world tasks, like understanding long documents or tracking conversations, require both local precision, spotting specific phrases, and global context, grasping the big picture. Traditional methods struggle to balance these. But with ROP and Alpha-Entmax, the model adapts dynamically. It's not a one-size-fits-all approach. It's a flexible, frequency-driven system. The results? Models can handle longer sequences without losing track of details. It's a step toward AI that's not just powerful but nuanced, like a human reader who knows when to skim and when to linger. So next time you see an AI processing text, remember, it's not just reading words. It's rotating vectors, slicing attention into precise windows, and making sense of meaning through math. Thanks for watching, stay curious.